But basically, it's mostly about C. I'll touch Haskell very minimal. I know some of the people here are not used to functional programming either, but basically, it's trying to understand what the type system is and how to implement those in pure C. So it's kind of like instead of programming on very high level type systems and bring that into C and unleash the power of the dark side, you build those things by yourself and you can expose some of the powerfulness that cannot be seen in other languages. And Felix, I just joined Google. I haven't get on board yet, but I'll be working on Google Cloud infrastructure. Previously, I was working in OpenX as a big data engineer. I was a tech lead. And previously, I was working in supply frame. We organized like 300 terabytes a day data volume. I was specialized in Hadoop MapReduce framework and high runtime. Nothing related to C. I just started to program C in a hard way, like in this month. Yes. Yeah. But anyway, so let's get started. What is a programming type? Anyone know a very good formal definition? Like, no? Anyone want to try? Cindy? No? I suppose you know it. Anyway, so before we give a formal definition, let's look at some examples of programming types. So there are primitive types like integer, float, pointer, or array. It's actually not that primitive. Some people consider the type some sort of primitive types. Abstract data types, stack, queue, tree, container types, function, interface, classes, generics are also considered the certain kind of types. How did you get a unified definition for it? So I picked a quote from Benjamin C. Pierce. So he's the author of the Types in Programming Languages. I think this definition is the most precise one. The type system is the syntactic method for enforcing levels of abstractions in programs. Kind of vague in a sense, but I'll give you some examples of why this is very true. So think of a C program. C program converted into assembly. One integer plus one integer is add L, EX, and EBX. 1.0, like two floats adding together, it's using instruction add SS and with the two floating point registers. So it's kind of weird. Like you have one operator or one function. Like operator and function are the same for Haskell, and I also consider them same in C languages. Also, if you have pointer arithmetic, like if you have a pointer incrementing by 1 with a different type it's pointing to, it's actually advanced with a different length. So if you have a pointer to an integer, if you add 1, then actually it moves its address by 4. If it's pointing to a void pointer, it's a pointer to void, then when you advance it, it's only advanced by 1. This 1 is just like moving 1 byte. And pointing to integer, it's moving by 4 bytes because integer is 4. So, what are the similarities for those types? So there are all different types, but with the same functions, like or same operators. But with the same operators, when you have different types, it operates differently. So types is like you have a generic operator, but within different types, it has different behaviors. So that's, you can come back to, a type system is a syntactic method for enforcing level of abstraction. You are using the same abstraction, like the same operator, but it's beyond or below the current abstraction, the type already defines how it's going to behave. So you can easily program different types. So thinking of the same thing for the, for example, object-oriented classes. It's basically defining a data chunk with different type of methods. Those methods may have the same name as the other class has, but with the generics, you can say, okay, since I'm having this class using this method, it's going to behave in this way, and for the other class, it's behaving in a different way. And similar to Haskell, in functional programming, it's still the same. You have a type class that is defined like monad, monoid, functor. Those are just defining type signatures. But with the actual type instance, like the data instance, like maybe, it will behave differently with a different instance type. And also, if you look at what types are, the types doesn't have to define all the behaviors. You can have one instance type that implements multiple of those. Like in Java, you have like one class implements like one interface, the other interface, and the other interface. And in Haskell, you can also have a data that is an instance of like several different kind of type classes. And a container class also, a container object can also be a partial type. It's accept another type and then it can operate. So all of those are built-in abstractions upon like to have a shared code that can be used different places. So I'll think of those kind of abstractions as a power of force, and I want to bring that into C. So on the bright side, you can have Haskell or Camel that has a very abstracted data type. You can easily have stronger inheritance, or if you know how to program really well, you can use it to write more concise code. Java, C#, or C++, those are like traditional object-oriented language. Also, I consider those, I start to get more used to strongly typed languages. So dot-typed languages are kind of excluded here. Yeah. The dark side is, well, bring that into your own runtime. So to do this, I don't want to just build a toy project or a prototype or a proof of concept. The rationale why I build this is to build real programs that I want to use in future. So before I say the actual implementation, I will give a little bit rationale of what I'm trying to build. I want to build a high-performance serialization library. What is serialization? That is having an off-heap data. For example, like JSON. You can share JSON between your server and your client code, and it's basically a representation of data that doesn't have to store in memory, but then can be restored probably across languages back into memory and then represent the actual data, its original meanings it holds. So to build this library, I want it to be extensible and to create a lot of partial types, like abstract data types that has common shared code. So it's give like half of the piece of the code that is shared by everyone. You just have to plug in your specialized code, and then you can create an actual type that can operate. And this library has to be embeddable. So I don't want to write same library for all languages in different languages rewritten. But I want to write it as one C library and then can be embedded into multiple languages. Because none of the language I know so far have serialization built into that language. And well, creating one language like that is one way. I did think about it, but it takes more effort. So instead of that, I want to build a C runtime that can be embedded into like existing language, and it's also easier to I don't know, motivate people to use it. Yeah. And also minimize the overhead of building strong abstraction over those objects. If possible, zero overheads.
What is a partial type?
So here I don't have a very good definition of partial type. It's basically, for example, if you have a list, without people inheriting it, you cannot operate it itself. You need to have plug in another data type or inherit it. Or you can think of an abstract class in Java that is a partial type that you cannot directly operate on it. Yeah. So it's kind of like some shared code that doesn't have an actual instance yet. Is that clear?
So is it something like Java interface, or it's like more like there will be more shared code?
Yeah, here I'm more referring to like an abstract class in Java instead of interface. Yeah, because interface just defines a signature. The function signatures doesn't have the actual code. But here, well, actually both are important in this library. Yeah. But for the partial types, I'm referring to the abstract class in Java.
Sorry. Can I call it a type constructor? Like Haskell?
I have to be careful of those terms, but I think what you're thinking and what I'm thinking is the same. But I don't know if there's a very good definition of type constructor for in this case. Yeah. So to build most of the so since data type is basically abstractions, and I want to pick some of the abstraction of using the library. So basically, I want to create. I think yeah, it's here. So here, there's a Java example and a Haskell example. In the Java example is, for example, I create a partial type tree, an abstract tree, and then it just says it's implement serializable, and it's a set object that is serializable. And I just have to call, for example, do I have a cursor here? No. So, this type implements serialize, and to serialize it, it's serialize some of its own code, and then I just need to call its internal object serialize. And that's basically what I want to do. That is a general function that can take in any kind of instance and then call the actual implementation of those. So I don't have to know like the input objects, what is their actual serialization function is. I just need to put it into the serialization function and then to find the correct implementation form. Yeah. And for people that doesn't know, actually, how many people code Haskell code here? Many, but not everyone. I'll just go through Haskell examples pretty fast. So Haskell, you create class, which is like an interface in Java. So you can have functor that implements that has a method that's fmap, applicative, applicative. Maybe it has a what is that method name? I forgot. Kind of like apply, and the monad has something like a bind. So actually, this angle bracket with a star is apply. The thing that looks like a fish, or I don't know, is bind. Yeah, but basically just define signatures of things, and then you can have an actual class instance that is turned in Java. In Haskell, you define a type with a keyword data. It contains like nothing or just a, which is just a water. And then you define the actual implementation of those function signatures. And then, well, in short, it's like if you have fmap taking a function in, and then if your input is a justified, it just apply the function on it. And if your data type is nothing, and then you just return nothing. So it's basically, it abstracts some code out of your plugged-in functions. So basically, I think the powerful part for those type classes or interface is that you don't have to know who is plugging in, but you can have a lot of common shared code in those, like more like a factory class that operates internally, and you just plug in different kind of objects into it. And each object just need to implement certain kind of like function interface or a different kind of callbacks, and then to operate automatically. Yeah. So it's basically just implementing generics. Yeah. Sounds like scary, but in general, it's just generics. So here is how I'm going to implement generics. So there are objects. The type class I named it as traits, and the traits is an actual instance of those are objects, like in memory representation. Like traits A has 3 function pointer methods. Each function method points to the actual method of that class. And when the object is going to being called for trait A, method 1, for example, it looks through which class it is, it looks through which trait it has, and then it looks finally find the actual method. So, in short, here is a simpler version of what gets implemented. So, for example, if you have an fmap, you have an object that's being passed in, and you have argument of the fmap. Actually, it won't be implemented as a variable that's argument, but actual argument passed in, because that's more optimal. It's puts the argument into register instead of stack. But anyway, so each object has an ISA pointer. The pointer is pointing to the class. All the same objects with the same class, they point to the same class instance. And for the class, you can get an array of traits pointer, and then you look for the traits name if that is the same as functor, and then you typecast it into functor. When you typecast it into a functor pointer, you can get the actual struct instance of the function pointer to the actual function. I hope that since it's kind of difficult to read. So basically it's just follow like this line to the actual implementation. That's what it does. There's an optimization you can do with this kind of a function. That is, since all the object is sharing, all the function object with the same class is sharing the same class. They share the same class instance. The class address is like a unique identifier for all the same implementation of its own. So in actual implementation, I use that class address as a cache key. So it looks for, it first look at the cache for that address if it is there or not. If it's there, then it will use the value stored in there, which is the actual function pointer, and then call it. If not, then it goes through this path and then find the implementation, store it into the cache, and then call it. Yeah. But it's a little bit too long to fit into a screen. So now we know the runtime behavior, but if you think in terms of how you're going to write it in C, it's kind of annoying because, for example, this implementation is not generic things that you can just simply copy and paste. Each of the function signature, you need different names, you need different actual address, and their arguments are different as well. Luckily, copy and paste those kind of runtime code is not a good way. But we can use macros. That's where macro shines. In C macro, string, like for example, your string as a struct name, or your string as an actual string in C, like you can convert like functor as a string doing string compare, or you can use that signature as a typecast. It's all possible. So actually, for that, you can have a macro that generates all those code. Yeah. Okay, actually we can jump to the code to see what those macros look like. So here is the method factory. It is clear to everyone? Okay, yeah, but basically what it does is, for example, it checks for the method ISA, and it also has internal cache. Where it is? Oh yeah, so basically to support multi-thread environment, I also use atomic load, and then there's this method cache is basically the cache, and if it matches, then I call the function. If not, I loop through the traits, and then for each of the traits, I can get here is a typecast back to the actual trace type, and then get the method, and then puts it into the cache, and finally call the function. Yeah, it's possible, and the final implementation looks kind of pretty nice. Like if I look at maybe let's see, not maybe it's say moment. Let's see. For the type, I just need to put the factory in, and then it generates the code. Yeah. So as long as it is not having bugs, macros are good. So let's get back to the presentation. Yeah. So, since this is a format B table, so there are relationships along like one class may have multiple traits, and the trait has multiple methods. It's like one-to-many, n-to-many relationship. So we want to use macros, but yeah. So the last part is the most critical one, which given a class, it has a many-to-many relationship. But the C macro is very weak. So weak. It's been a very, very difficult time for me to hack around this. So first, it has no for loop. So the many-to-many relationship, like one-to-many relationship becomes very, very tricky. You cannot put the macro argument in if-else, so it's equivalent to having no if-else. Third, it has no arithmetics, so you cannot add 1 or -1 or any kind of arithmetics. It's not allowed. It has no recursion. Like, what can you really do with macros? But it turns out it has one good thing, just one good thing, which is called variadic macros. What the variadic macro is the syntax is exactly like this. You define macro A, taking x, and then dot dot, like literally 3 dots. And then in your macro, you can reference the things passed in by VA args. And then, for example, if you put A with fmap ABC, it will be become like fmap ABC. Right? It's those like clear to people. Basically, just string replacement. Just having this is good enough to create all those crazy macros. So how do we generate a for loop from C macros? So it's actually more like a functional programming style. And I also named this as like functional programming paradigms like map. Also, I use map and reduce, that is more like closure terms, but it's also possible to name it as map and fold. But anyway, first you create something similar to recursive structures, like map 1, map 2, map 3. Map 3 calls map 2, map 2 calls map 1, and to take the arguments out, you just need to say in the map 3 you have fx and 3 dots, and you take the x and call the fx, but when you call F2, you don't put the X in, you just put the variated macros in. So you decode, you take out one argument, and then paste the rest of the arguments into the map2. Yeah. But which map you should pick? Like if you have 6 arguments, you always call the map6. It turns out that having, what is that, currying is also possible in macros. So you can create a macro called get macro, and say we don't have 3 arguments. We put get macro 1, 2, 3 and then, and returns name. And you define the general macro called map, and you call it with get macro with the variable argument and the map order from map 3, map 2, map 1, and then the actual arguments you're going to put in. So how it's going to work? Say you call map with 1, expand the get macro by 1, map 2, map 3, map 2, map 1. It returns a 4th argument, right? So it will return map 1, so it will call map 1 F1. And with different arguments within 3, it will work. Yeah. So that's how you can generate for loop. And it's actually, since in the expansion of the macro, you can do map and also fold. So basically, you can access the one that is going to recursively call and the accumulated argument. So actually here you can also define a fold function that takes the accumulated results. Yeah. So if you're curious of how it's being implemented, it's here. So here is my get macro by arguments. I support 36 versions, and the actual code looks more messier because actually I need to support scope variables that pass into the macros, because it's unlike C or any languages that has scope. I cannot look for outer scope within the macro, so I have to pass it in. So I support 5 scope variables that can be passed in. And this is how I support, well, it supports 3 things. It supports reduce, which is fold. It supports map, which is the n. And also it supports accumulated iterators. So it will, on the first call to the first macro, first map macro, it will see, I think it sees 0. And then the second call for the second expansion to the map, it will see 2. So you can generate something like a struct that has like maybe 5 fields, and the 5 fields are initiated with 0, 1, 2, 3, 4, 5. 1, 2, 3, 4. But I said there was no arithmetic. How do I add 1? So in C macro, there's something called concatenate operator, which is 2 pound sign. And by expanding that pound sign accumulating ones, some of you might guessed, it will become something like this. I append more ones, the one with the more ones expand to a larger number. So that's what it is. So as long as you have something that's programmable, you can always make it functional if you want to call it functional. Yeah.
Do you call it by hand? Or you use a program?
Well, mostly by hand. Well, by Vim, it's kind of like in the middle, right?
Macro, yeah.
Maybe I should program this in Emacs so I can have real Emacs macros to do things. Well, EIS macros too, so it's kind of similar. But anyway, actually this covers like half of the stuff like Haskell Typeclasses or even functional programming in C macros, which is kind of like a cool stuff. Oh, I didn't mention like the actual call to those macros are actually kind of nice as well. So say if I want to do certain expansions, where it was like here I call an expansion and it's used. I need to pass in a macro, which is like a macro function, a macro into it, and then the actual macro defined here, it takes in the things that's going to get iterated through, and the scope variables being passed in, and it also calls another macro, but anyway, it can be done. So I think this is almost the last piece. I think this covers, yeah, it's already covers what I want to say. So some of my macros are like inspired from another macro system called P99. Well, initially I used P99. It's kind of like preprocessor 99. I guess the name comes from like my expansion is 36. I think it initially was expanding like 99 recursive calls, and now it's like 159. Yeah. But it doesn't contain like more than one scope variables. But I need to contain more scope variables into my recursive macro extensions. So yeah, and some of the detailed implementation for mine and theirs is kind of different. My evaluation is like in order, their evaluation is like reverse order, but anyway. If you want to know how much you can push into macro system, my project and their project is both interesting to see. Yeah. So, I think that is the last piece that is more relative to functional programming. The rest of the part is like how I'm going to, well, it's still kind of related to type systems, but not that much to the functional programming stuff anymore. Yeah. Oh yeah, here are some of the questions I got from many people of why I don't use C++, why I don't use this language and other languages. Actually, I have very good reason for all of this. So, I considered a lot of languages for my serialization project, and some of the reason, one of the best candidates is C++. It has very nice type system compared to C, but there are certain things that doesn't fit into the scope of my project. First, it's hard to embed into other languages compared to C. Second is the most important reason, that is, so I talked about the type is a behavior of certain data objects. But to serialize that data object, if you cannot deserialize it back with those same behaviors, you are very limited on what kind of data you can serialize. So, for example, when you serialize a C++ object, how to serialize its B table? I'm not sure. I guess it is still possible, but probably difficult. And getting those solutions and cross-platform, cross-machines, cross-different versions of C++, maybe like this C++ implementation cannot be deserialized into that version of C++. It's possible. I'm not sure, like, if I want to hack into that, but C, I already have one solution. Yeah. And in the second part of my talk, I'll talk about some more detailed memory control that can be easily done in C, but probably not that easy to be done in C++. Yeah. Also, some of the common C implementation of object-oriented program is instead of one C object pointing to a class, you have one C object that has all the function pointers embedded in each object, which is more natural to do, less overheads, but C lacks of like expressing this. Like, I want to accept a C object that has a struct field A that is type A, like implementing, like having accepting a type class, accepting setting an object that implements a type class. This kind of stuff is like not able to be expressed in C. Although you can raise exceptions if you find it's not there, like comparing to those traits. But C structs fields are not reflective. You cannot query those names in the runtime. And also there are two other nice candidates that I considered, Rust, Swift, and Go. Well, Go is actually, their type system is not very strong, so I excluded it very soon. For Rust, it's actually a very, very nice candidate, but I didn't consider Rust and Swift for the same reason why I didn't consider C++. How do I serialize their internal data structure? Like, if they have reference count, I think they are not using reference count, but like garbage collected probably. But
actually, Rust doesn't have garbage collector, and you can use very native structure in Rust.
Oh, okay.
Yeah, but of course it's more complicated than C, maybe just a little bit. But so maybe in your version 2.0 you can consider it. Yeah.
I have a question. I heard that they are planning to add garbage collection.
Yeah, they are planning to do that, but so far I haven't heard they have such decision made. Yeah.
But
Yeah,
Rust is actually,
yeah.
I do seriously consider Rust because they have natural traits, and they can.
Yeah, that's one reason.
So it is a very, very strong candidate.
Yeah.
I agree. Yeah. I might, if I can implement the serialization I wanted to do in Rust, it probably would save a lot of efforts I have made so far. Yeah, but it is a very strong candidate. So what is my next? Oh yeah, so the next part of my slide is all about what I've done in serialization, and particularly how I created, successfully created one serialization model for pointer machines. That is basically, most of the object-oriented system is like pointer machine. You have a constant field of object that can reference to other objects, and you have some inbound and outbound pointers to it. So basically, it's like creating an object system that can be serialized in a general and a fast form. But I'll give a more formal definition of pointer machines. So yeah, let's get back to what is serialization. It's a data representation that is interchangeable to its in-memory forms, and if possible, cross machines, cross platforms, cross languages. You can consider JSON, XML, CSV are serialization of primitives, or some like string objects. Protobuf and Thrift is a much more efficient binary form of serialization. But you can also consider database and search engine as some sort of serialization. It serializes some data into this that is durable, but it also presents some types. It presents, well, it's a complex type, but if you say types as a representation of behavior of something you can program with, can interact with, it is some sort of complex types. Although you can interact it with a very high-level abstraction like SQL, or like just putting a string and it returns a list of web pages, but it is still some sort of serialization that I want to like unify. I want to unify all those perspectives into one serialization library. There are some, if you break it down into smaller pieces, there are some common types of serializations. There are doc typing that doesn't really have types. You interpret them in your program that's assuming it has some certain structures like CSV, JSON, XML. There are some serialization that is more type strict. That is protobuf, Thrift, April, flag buffers. You specify a schema before you serialize it, and then your schema can grow over time, but it can still read the old data. Yeah. So your schema is kind of at least backward compatible to your old data. Yeah. As long as your data type has an ID. April doesn't, but kind of similar. Third serialization that some languages implement, like Java can serialize some object, like you have a hash map that implements serializable, and you can just serialize it. But it is often often fat and slow. Like it's a big memory chunk, and it's walked through like its implementation, like its internal object, and it's basically just very slow. And a lot of other languages doesn't have serialization built into their language design, and also those object serialization are often language dependent. Specialized serialization that's like a lot broader scope, that is like database, search engine, or some of the, I'm not sure, like, some of the rendering engine, like they render a scene that can be reused or further being rendered, that is kind of like serialization. Anything that you can store into disk or can transfer over a network is some sort of serialization and often has some special use. Well, I try to do a very general serialization engine, but it's very difficult. I have to pick some parts that is easier to serialize because there are always trade-offs. You need to pick something that is easier to break through but still general enough. So there are models of computations. The highest model is called cell probe. It's usually used for analyze only. So it's basically saying all the arithmetics, all the CPU computations take 0 step. But accessing memory just counts as 1. Like accessing anywhere in the memory, and your memory is infinitely large. Second is a RAM model, and it's a family of different kinds of RAM model. RAM model is saying like you have an infinite large random access memory, but your computations still take steps. So it's used for analyzing complexity. There's a special RAM called word RAM, that is you can only use common integer and pointer arithmetics like plus, divide, modulo, like those kind of operations. It's more general, a smaller scope of Pentium RAM. That is Pentium RAM. They are said to be implementing all the Pentium Intel Pentium instructions, and word RAM only implements a subset of it. RAM is like infinite. It also has a property that is your memory size is exponential to your word size, like 2 to the exponential of your word size. That is because you can only use your pointer to address that's large. Like if your word contains a pointer, your pointer address space is your RAM size. Yeah. And then compared to those, there are pointer machine. That is, you have a constant size of object. Actually, there's a next slide that is, it's very simple. It's, you have a root. You can have, each object is a constant size that has a constant number of fields. And you can do like, each of the operations here is O1. That is, you can create a new node. You can assign the field into the node. You can destroy the node. Those kind of operations are called, is physical pointer machine. And actually, most of the object-oriented program is a pointer machine. So it's a more academic term for object-oriented programming. And actually, your Haskell programs are still pointer machines. It's general enough. Now, the last part is binary search tree. You can have very, very limited operations that is only rotate, walk, and assign like new nodes, and delete nodes. There are certain interesting analysis on those things as well, but out of scope of today's talk. Although I say I only implement like, I want to serialize a subset of the possible models, but pointer machine is already general enough. It's very powerful. Like most of our programs are fit into a pointer machine models. But pointers are very bad. It's not that easy to serialize. Why? Because your pointer is to an address space in your process, but your process may have a new address space in the next time. Your function, though, most of the time they are sitting in the same address, but it's not necessary. Crossing machines, probably not. But almost everything except object. Object means like exact memory representation in C memory chunk. That is like primitives, structs, everything except that even arrays are pointers. Array functions are actually like array, like a pointer. The implementation of our class and traits, all those things are pointers. So we need some identifier to those things, those actual objects across processes. Best of all, that's across different machines or architectures. I haven't found a good way to make it across architectures, but kind of, well, that's probably need a lot of redesigns, but still. In pointing machines, things are modeled as a field. There are primitive fields. There are pointers within the data structures. So there are basically two types. There are primitive fields and pointers. Pointers falls into three categories. That is pointer within the data structure. For example, you have a binary search tree. All those pointers pointing to each other are like the pointer within the data structures. There are inbound pointers. That is probably a pointer to the roots. And you have some outbound pointers. Basically, it's like if you're pointing to your vtable, your class object, that is an outbound pointers. Each of those are handled like separately. So primitives like no op, you just serialize it, probably have to handle the intiness. But for internal, but basically that is like no op, right? Internal pointers, we need to do some conversions. So how do we design an identifier for internal objects? One way to identify it is by type and a unique ID for that type, in that type, like an array of sets. So instead of pointing to the actual memory location, if you can having an offset, like assuming all of your types, the same type is a large array, then you just need the ID and then you can point to it. And that form fits into a serialized memory form. And if you want, you can also deserialize it back into an actual memory pointer. So it's an easy operation to convert it to and back. To do so, I need to manage memory pretty well. So for that, I create a memory allocator for each type. Well, each collection of types, because you might want to serialize a data structure that contains multiple types. Like, for example, you have a field that is not a primitive, but pointing to another constant size of some objects. Then that object needs to be also like a type of an array of its own, and then just need to point to it, and then that contains the actual objects. Yeah. And when you manage it into a large array, serializing a large, like a book loading array is fast and easy. So that's the basic idea how I create the pointer machine serialization. It's only have 4 plus 2 type signatures. Only have 6 functions is sufficient. Well, actually, there's 2 more that is create and destroy the manager object. But still, alloc with a class object, with a class pointer, and you can also free the actual pointer to the object as long as it is managed by the correct memory manager. Serialize, deserialize, and it has 2 callbacks. That is, convert a pointer to a reference. The reference is the unique identifier of the type plus offset, and convert it back to the pointer. Here is the object relationship layout of the memory manager. So it's actually, all the term is exactly the same as how I write it in C code. Memory manager contains 2 lookup maps. One is called type map. This maps from the class address to the PM pool. A PM pool consists of multiple PM slots because maybe our initial slot is not large enough. I need to create a larger slot that is like twice as big as the original one. But I don't restore the pointer point to it, it still sits there. It's just like when I serialize it, I pack those slots together. Yeah. to do the to free the objects instead of freeing it back into the map function, the real memory allocator. I use a heap to manage which objects are being freed. So I can, if I want to add up a new object, I can get the smallest address out quickly. Yeah. So it's also a very nice memory representation that can avoid memory fragmentation. Yeah, since all the data array is in the same size. The bad part about this model is I lose almost all the type information. I have to store how large the object is in the class object. Yeah, but it's still possible. Since I'm returning void, it's still kind of I kind of have a little bit of runtime type information in the runtime. Yeah, and to know what pointer it is being stored, which slot is being stored, there's another pointer map. Basically, range tree that's you query for a pointer, which range it falls in, and then it goes to the actual slot. It's just a binary search tree.
Can I ask a question? The ISA pointer that points to the class, right?
Yes.
That is also being serialized?
Well, I converted into I just converted into a -1, just like all turned on bits to differentiate from object that is free. A free object always converts the actual data storage to all zeros. The reason why I convert that is I want different programs serializing exact same data structure and have the same behavior, like the same data. So although they may point to a different address at their runtime, but I just put them as all ones, like all turned on bits. But
so the ISA pointer doesn't really get serialized, but you serialize the type?
Yes. So I serialize P and pool. I serialize like for this this type object. I first serialize its name because names are shared, right? It's I cannot use ID because ID generated from different programs may be different. But the names I say it's a list, then it's a list. So the name of the class is being serialized, and then when I deserialize it, I look up the name, get the actual pointer, and then restore the pointer back to all those turned on bits.
Yeah. So this, of course, only works if you use the same class implementations.
Right.
Yeah.
Yeah. I don't think there's a better way for that unless you serialize the executables.
Yeah.
Yeah. And if you do that, things get even more messier. Like I don't think there's a good way. Yeah. Yeah. So if you want to support multiple versioning, you probably need a converter to read through it and then store it into a newer version. Probably. Yeah. That already covers some things in this serialization steps, but I'll go through it again. So first, I need a unique identifier for each type. That is a class name I'm going to reference to. So first, I sort the PM4 by the class address, basically like sorting the types that is being stored into this memory manager, and their index in this sorted types is the ID that I'm going to refer to. Yeah, and then copy the. Since I'm going to change the memory representation of those pointers, I cannot modify the runtime one. I have to modify the copied one. So I look through those pools and slots and see how large they actually contains, and then pack it into a big pool. Pack it together. Like if I have this pool being used as a hat, and I only use the one that's being used. Yeah. And then I call serialize for for that object, and the object should implement the serialized function, and then you have a callback that converts their pointers into the type class of sets, which is the reference in the pool. Yeah. Finally, I need to convert all the outbound pointers. Basically, that is a class, and I just put all turn on bits, that is -1, and yeah, and finally store the class name as a string. Yeah. And finally writes the pool out, like writes all those converted temporal buffers out. Yeah, this part, yeah. But how do I, so now I know my serialized data has the outbound pointers represented as strings. How do I restore it back into memory? There's a trick in C that you can run some functions before you run main. That is assigning an attribute constructor. This is by default turned on feature in GCC and CLAN. So you just need macros again to declare certain functions that register the string name and their function, the pointer to their instance before main is being run. So when you read it back from this by the string, look up into the map and then find the pointer and then reassign to all the types. And once all the types are being assigned, then you can now you have the type, then you can deserialize it. Before you assign the types, you cannot deserialize. Yeah. So yeah, the third part, basically what I just said. Yeah, there are some examples of the actual code. I just finished this program yesterday at 2 a.m. So let me see. So here, I create a memory manager. I initialize it, and I just make. Oh, sorry. I need probably better to pull out the list. So it's I don't even put like partial types. I just create full type that's its value is just integer. If I don't create a partial one, I probably should put a pointer or something that can contain other values. But I just want to test if this can be serialized or not. So it's a struct, and it's reference to the class that can point to the class. And this declaration is just simply declare that there's a class object that is external, implemented in the C code, which is hide behind another macro. Because I don't want to hand code it, people might mistype things. Yeah. And on the serialize and deserialize, it's basically very simple. My struct only has one object that is list, and I just need to set my internal pointer with so this PM serialized pointer to reference. I put the pointer address in, and the actual context. The context contains the those pointer map and so on. So in the serializer, it's look for the slot that it points to, and then say, okay, this slot belongs to this object pool, and then gets the reference out. Yeah. Yeah, some debugging messages here, but serialize and deserialize. I hope those kind of boilerplate code could be implemented in macros, but apparently struct is not reflective. I cannot say look through all the fields I have in a struct. Oh, if this is a pointer, do this. If this is not a pointer, do that. I cannot do that in C. Yeah, so I need to put explicit deserialized functions to do those things. Yeah. And yeah. So basically here I just create a linked list of 10 items, and if I run it, basically I print some of the how the memory is being allocated and different nodes with different values. And the other program, read. I open the serialized objects and then read it into a context and then just print it out. And what that does is simply this time, yeah, it just prints the same, well, with different addresses, of course, but it stores the exact same values. I can also use where is my X5? I'm not sure if I should. Here are all the serialized pointers, the ISA pointers. They are all -1. So actually, it's a good way to debug the stars of an object. Yeah, and yeah, that's basically almost everything, like from high-level view of my presentations. I think I have 2 more slides. Yeah. So I also think of some other challenges in this project. Like, is it possible, at best, in compile time, to enforce abstract data types to accept certain types only or certain traits only on compile time, not runtime? On runtime, it's easy. I just need to assert, like, it doesn't implement this, I raise an exception or force the program to implement it. I haven't yet find a good way. I think unless I use Rust, I could not get it. Or I create a new language that is not an option, but that takes much effort and probably hard to use in other languages. Reflective struct, I mentioned it. Yeah, like in C, when I reference a field in struct, this information is available in compile time, but completely nothing at runtime. So I think the only possible way is to build your own runtime struct. But that is also kind of crazy, unless it's really hurting. Else I probably would go with that route, but that is one alternative. The third one is that is just like I was lazy, so I didn't implement trace inheritance and class inheritance. And probably it's not too expensive. I just need each trait and each class object needs another ISA pointer to its inheritance. And in my method call, I just need to iterate through those inheritance. And since I'm going to store the actual function pointer into my cache, it doesn't seem to be that expensive. So that's probably not difficult. Yeah. Another possible thing that's interesting is now you can do JIT in C. GCC 5 start to, I think, 5.1 or 5.2. You can optionally compile your GCC that supports JIT. For that, you can now have your string representation of your struct mapped into actual offset of your struct objects. But the project state to be experimental. So, but still very interesting. Yeah. So yeah, that's the end of my talk. It's kind of a very large scope project. I don't know if people enjoyed it or not, but a lot of crazy ideas in this project. I think the best part is still the C module. It's very cool. Any questions?
So the user of this library should prepare each data type with serialized and deserialized function in C.
If you want to serialize, then you have to, but it's not enforced. It's I only check for it is implementing serializers for my serialized. So you can still at least use the same memory allocators without having your method implementing serialize. Though probably you can just use a regular memory allocator, and you can still have those type classes.
You didn't provide a schema like data, so metadata. So the library didn't know which field is a pointer or a pure data. So we need to provide our own
Yes.
serialized.
That's why I said having structure be reflective is useful. But
Reflective is also a metadata for the
yeah, it's like, okay, if I know this drop has 5 fields, 2 fields are primitive, 3 fields are pointers, I can just say for those 3 pointers, run the serialize function.
Maybe you can use a C macro to build reflexive structure.
It is. I did seriously consider this. But the hard part. Well, actually, it is possible. Like you can say, if you say like, okay, well, a macro, and then say, okay, this is the type of the first field, type of second field, and then you decode 2 fields every time, and then you can rebuild. You can know all the type name, and if you can infer some of their behavior by the name, probably need some other stuff to do that. Yeah, since you cannot have it else in macros, still probably difficult.
I think it's easier for us to provide just a plain schema data than a piece of code. That would be much easier to make something work.
Yeah. Yeah, like if you can, well, it's still kind of, well, say you have a string representation of your struct, like as a schema object. But for each field, what is the actual offset in that struct is you still need like some lookup to do that.
Could be part of this description, right?
Yes.
Could put
Part of the
memory
schema.
offsets.
Yeah. And if you actually do that, I think that is kind of rebuilding struct of your own. You're basically, I guess, in the end of that is instead of having a struct, you have a void pointer to a chunk of data objects. Like it just like bytes, and then you store a schema that points to different offset of the byte, and then interpret it as certain kind of types, like typecasting to certain kind of types, and then you can have a reflective struct. Although you cannot do bits padding in that kind of representation, but that is possible. Yeah. That is, I think, instead of JIT, I think that is the most possible route.
But you still can use normal C structs, right? Just with a redundant description of how the struct looks like.
Mm-hmm.
in
Yeah,
the S
I think the one thing that I considered was if you turn on different kind of optimization flag, your program will actually they'll change the order of how your fields being ordered in struct. So you need to export those informations into and also consider you might have bit pattern, like this field consider 1 bit, that field consider 2 bits, and it's all you need to know exactly what instructions to decode it out. It is also kind of tricky. Yeah.
I thought that even if I turn on optimizations, C compilers does not read all the structs.
Actually, not optimization. There's a attribute you can say packet.
Yeah.
I always say packet.
But that just means that there are no paddings.
If you always enforce the user cannot use padding and hack attributes, maybe. Yeah. Well, it's all kind of trade-offs. I'm not sure what would be the best way. I think to be safe, you still have to build your own prompt. Or use JIT. Maybe that is also another possible way.
You always write something wrong.
Or build your own programming language, which is also another good way. Then you can expose all the compound information into certain, like a subset of them into a runtime information that you can access.
Maybe just build a preprocessor for C.
I did try to use GNU and 4. Yeah, that is one possible way, but it's still kind of like I need to do two compilation first. I'm not sure. Yeah. GNU and 4 is a way better macro system than C macros. Although its syntax, I don't know how many of you have used it before. Its syntax is very, I can show you. I should. The most simple form is, this one doesn't tell anything. Maybe I should clone my own project back. I just need to look at the online version is sufficient. Yeah, this is the one I contributed. Some of the other macros was terrible. I think my macro is a little bit more oh, not this one. This is some other people. Weird. Oh, yeah, actually, this one. Oh, yeah, this one. It's some weird form of list. Although it's not using prefix operators, but I wouldn't expect people want to use this to program in C. Yeah, but it's a very, it's a general macro system. I don't know if there's other good general macro systems. This is one of them. It's old as me. If I couldn't solve some of the very difficult problems in C macros, this probably would be my next candidate. Although I did solve my two recursive, like two for loop problems, and so far I think that is good enough. Yeah. And I think including another preprocessor would make the project even harder to get adapted by people. So that is also a consideration. Yeah. Questions?
If I build a new list of type A, and the length of it is 10 elements, and if I delete those 8 elements in the middle, what will happen when you serialize this list with only 2 elements?
Well, it will still serialize those garbages. That's not being referenced. I plan to do garbage collector independent of that memory allocator. So probably we'll create a extension of the original type class that has something like reference counts or like junction connection, you might have colors, like different types of the states of that object. Yeah. So far, it's just try to make those. Sorry.
When you deserialize those garbage, that the instance in the new process will know that there are holes to be used.
No.
So the garbage will persist for.
Yes, forever. Well, I still like the idea that I decompose different components. Like I can still have my, like for example, you can still manage memory of program that doesn't have garbage collectors. You just plug it in, and then you run it once a while, for example. Yeah. And I can still take my memory allocators object in and extend it somehow. So that is okay. Yeah. I can extend my memory allocator with maybe some other meta information object or maps, and then it can be used in this context, but also it is memory managed in a more general form. Yeah. Just to put those pointer machine to work, this is more stress every day. Because although now it seems trivial, like memory allocator should be built in this way, or at least that way would work, but initially it wasn't that clear. Like I didn't realize I need to manage the outbound pointers until probably the day before yesterday. Yeah, maybe yesterday. Yeah, but luckily those outbound pointers are very limited. It's just type maps. It's just like the pointer to the ISA classes. So. Although it's not that functional programming, but I hope people feel the fun part about programming languages and types. Thanks everyone.
We now take a rest for 10 minutes, and I think today we have a lightning talk from. Sorry, I still don't know how to pronounce your name correctly. It's from Luca, who is from Singapore, and anyway, it's just just take a rest for 10 minutes. Yeah, thank you.